Hi everyone. In this video, we will discuss about the induction motor, a most versatile motor which is being used in the industries, and more than 95% applications are based on the three-phase induction motor. And also, the earlier versions of the electric vehicle have also deployed the induction motor. So it is very imperative to discuss and to understand that about this induction motor. So let's start with the video. So let's say where induction motor gets placed. So we have broadly classified the AC motors and the DC motors. So these DC motors, all the variants we have already seen in another video. Here, AC motors, we have the major two classification. One is the synchronous motor and other one is the induction motor. And under the induction motor, we have again the two classification. One is the squirrel cage induction motor and other one is the slip ring induction motor. These two variants are classified based on the rotor design. So in induction motor, specifically for the three-phase induction motor, we have two types of the rotor design. One is the kind of a squirrel cage, other one is a slip ring, and based on the rotor design, the two classifications of the induction motor has been given over here. So induction motor is also called as the asynchronous motor. This name is given because it always lags behind the synchronous speed, or in other means that it does not run on the synchronous speed. Whereas the other variant of the AC motor, which is the synchronous motor, is always runs on the synchronous speed. So to understand the synchronous speed, as of now, we can say that the electromagnetics which is being used over the stator to create the electromagnetic field, or the windings which is being placed over the stator to create the electromagnetic field, it produces the rotating magnetic field, and that field seems to runs at synchronous speed, which is given by 120 f over p, where f is the supply frequency and p is the number of poles which is being created by the windings which is being placed over the stator. So the stator of the synchronous motor and the induction motor is similar to each other. Their constructions, their looking, their similarity, all are same. So therefore, induction motor always lags behind the synchronous speed, and the concept of the synchronous speed and the rotating magnetic field, we will take it thoroughly in another video. Here, we have just to understand the basics of the induction motor. The man behind the induction motor invention is none of other than the Tesla, Nikola Tesla. He has invented the induction motor in 1888, and the clear advantage of the induction motor over the DC motors are it has a simple design as compared to the DC motor, because the rotor does not require the supply in case of the three-phase induction motor, whereas in the DC motor we have to give the supply to the field winding and the armature winding. It has a simple maintenance because it does not acquire the brushes and the commutator placed over the shaft as like in the DC motor. So therefore it requires a simple maintenance procedure, the simple control gear for the starting and the speed control, and it has high efficiency. It has the second highest efficiency after the transformer machine, because transformer is a static device which achieves the efficiency more than 98%, whereas the induction motor can easily achieve the efficiency somewhere around 94 to 95%. It has a low cost and it can operate in the dusty, and therefore it does not have the possibility of the sparking because it does not acquire the brushes. So this makes it a very versatile motor, because in the industry we have the dust, we have the oil contamination. So both the dust and the oil contamination is very hazardous for the DC motors, because it can produce the sparking and can further require the maintenance, where the DC motor can withstand in the very dusty and the oil contaminated environment. So therefore industry likes it, and therefore it's been called as the robust motors for the industry applications. So as I've stated earlier of this video, that induction motor also being deployed for EV applications for the earlier versions of the EV models. Why? Because it is particularly favored for their ability to handle higher power levels and provide good torque at the lowest speed. But nowadays, the most of the uh, models of the EVs are being equipped with the permanent magnet synchronous motor. So that also we will discuss in another video, that what are the advantages PMSM motor gives over the induction motor. However, here I have taken few examples or the few models name which is being deployed with the induction motors earlier. So Tesla Model S and the Tesla Model X of the earlier versions, they have been deployed with the induction motor. And Tesla Roadster, our first generation, or the first, which is the Tesla first production vehicle, the being equipped with the induction motor. Nissan Leaf's earlier motor also being equipped with the induction motor. Chevrolet Spark EV also being equipped with the induction motor. And in the current scenario in the Indian market, the Mahindra E and the Mahindra others EVs also being deployed with the induction motor. So it was the first choice after the DC motor being deployed for the EV applications. So to understand the induction motor, how it is being used for the EV applications, we need to understand that first, what is the overview of the induction motor, how does it look like, what is its operating principle, its construction, its power flow losses and efficiency relationship amongst it, and torque slip and the torque speed characteristic, because it is very important to control the motor. And lastly, the speed control, what are the various methods by which we can control the speed of the induction motor. After going all these aspects, which we will take in the series of the videos, we will discuss it thoroughly one by one. So we will understand that how an induction motor runs and how it can be controlled for an EV applications. So specifically the induction motor classification based on the supply system, we have two types of the induction motor which is being very popular. One is the single phase induction motor, and the other one is the three-phase induction motor. So the single phase induction motor, which is being used in our ceiling fans also, and most of our home applications are based on the single phase induction motor. But however, they are usually built in the small size up to the 3 HP ratings, whereas the three-phase induction motor are mainly used in the industry for the power conversion and to perform the mechanical task. And it also gives you the very high power rating and able to perform in any dusty and the oil contaminated environment. So here we are specifically going to discuss and concentrate over the three-phase induction motor, because three-phase induction motor is widely being used in the industries, and it is the motor which is being deployed in the EVs also. So to understand it, first let's say why the induction motor only. We have already stated all these points, that it is very robust because it has no brushes, it gives a very high power in the weight ratio, so it has a more power density as compared to the DC motor. It has a lower cost, easy to manufacture, and it's very kind of maintenance free because it can withstand in the very hard environment also. What are the limitations? I would not say the disadvantages. What are the limitations? That it employs the very complex speed control strategy, which is based on the supply frequency. So we have to vary the supply frequency to control the speed of the induction motor, which again we will discuss thoroughly in another video. So it is kind of a, I would say, the limitations, that it has some complex circuitry or the complex external circuitry for the speed control of this kind of a three-phase induction motor. So in terms of its construction and its looking, we majorly gives the two classification in terms of part. One is the stator, which is here. You can see that these windings, which is being deployed on the stator. What it does, we will discuss it further. And this is the rotor, which is the rotating part of your induction motor. The supply, three-phase supply, of course, is only being given to the stator winding, which is being shown over here. The stator winding is only being given with the supply, three-phase supply. The rotor does not takes any supply system, or it does not require any supply. So it is very interesting to know, or very interesting to understand, that how the rotor of the induction motor runs. And for the better heat dissipation factor, we also deployed the fan over here, which is nothing but for the heat dissipation, which further increases the efficiency of the induction motor. As I've stated earlier, based on the rotor design which is shown over here, so we have two types of the rotor design for the induction motor, and therefore we have the two classifications of the induction motor. One is the squirrel cage and the one is the slip ring induction motor. So most of us have watched a very famous movie, Three Idiots, a Bollywood movie. There's a very famous scene where a dean asked to his students that what you have learned overnight, and he answered that uh, induction motor. And then dean asks a question. So in that case, can you tell us how an induction motor starts? And he answered that vroom, 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 which is I would say it may sound like that, but it is not the exact operating principle or the how it starts. So therefore, in the next video, we will see that how an induction motor starts and what its operating principle. I hope this video gives you an overview about the induction motor, and also gives you a kind of idea that why it is being robust, and how industries like, or why industry likes the induction motor specifically for the three-phase induction motor. Thanks for watching.